Here we have a dataset on the prices of one-year-old used cars in 2005. You'll notice that each row is a different observation, in this case a different car, and each column is a different variable. Minitab has automatically identified which variables are categorical by putting a T at the top of the column. Let's investigate this question. In 2005, did a majority of all one-year-old used cars have cruise control? We can investigate this question by testing these hypotheses: the null hypothesis that p equals 0.5, and the alternative hypothesis that p is greater than 0.5, or in other words, p is a majority. Here, p is the proportion of all one-year-old used cars in 2005 that had cruise control. If we were testing these hypotheses on a calculator, we would need to check two assumptions: that n was less than or equal to 5% of the population size, and that n times p times 1 minus p is greater than or equal to 10. Both of these assumptions must be true in order for the sample proportion, p hat, to be normally distributed. However, Minitab can do an exact calculation for us that uses the binomial distribution instead of the normal distribution. That means that for a test of proportion in Minitab, we only need to check that n is less than or equal to 5% of the population size. In this dataset, our sample size is 20. "20 times the sample size is 400. I'm pretty sure that in 2005, there were more than 400 used cars for sale that were 1 year old. So 20 times n is less than or equal to the population size. So n is less than or equal to 5% of the population size. That means we're okay to do a one-sample test of proportions in Minitab. We can do that by going to the Stat menu, choosing Basic Statistics, One Proportion. Our data is in a column, and we have the raw data, so choose one or more samples, each in a column. Then click in the box below that menu to see a list of all the variables that you could do a one-sample test of proportion on. In this case, we want to test cruise control, so click on that variable and then the Select button, and then check the box marked Perform Hypothesis Test. The hypothesized proportion should be p sub 0, the established value that's in the null hypothesis. In this case, that's 0.5. Then click the button marked Options. We want to set the alternative hypothesis to match the alternative hypothesis we're testing. In this case, that the proportion is greater than the hypothesized proportion of 0.5. And we want to use the method to be the exact binomial method. We're not computing a confidence interval here, so it doesn't matter what number is in the confidence level box. Click OK, and then OK again, and the output from our test of one proportion will appear in the session window. Here you can see that Minitab treated yes as the event. That means that cars with cruise control were considered to be successes. So X is the number of cars in our sample that had cruise control, in this case 12. And the sample proportion of 0.6 was the proportion of cars in our sample that had cruise control. This matches the way we set up our hypotheses, that P should be the proportion of all one-year-old used cars in 2005 that had cruise control, or in other words, that said yes when we asked, "Do you have cruise control?" By default, Minitab will use the value that comes second alphabetically as the event. So if you have a yes or no variable, then you should set up your hypotheses so that P is the proportion with yes. If the values of your categorical variable are something other than yes or no, you might need to change the way you wrote the null and alternative hypotheses to be able to interpret the p-value correctly. In this case, the event is yes, which matched our hypotheses, so we can go ahead and interpret the p-value, which is the last value that Minitab gives us in its output. The exact p-value, that is, using the exact binomial calculation, is 0.252. There is not enough evidence to claim that a majority of all one-year-old used cars had cruise control in 2005.